Sorry about that rude interruption. Oh, you know what? It was okay though. I found a mistake. Can you believe it? Me making a mistake? I know it's so hard to believe. I forgot to put in -1 since it was decreasing at a rate. Okay, so I put the -1 in. I have -1 over 40 pi, and I'm really supposed to be finding the rate for the diameter. Thank goodness it's decreasing. I know because it's a negative. And of course, I could convince myself that it's nothing more than twice that if I write myself a little formula over here that the diameter is equal to 2 radius. So if I took the derivative with respect to t, it would equal 2 times dr dt. And I go, oh yeah, so the change in the change in diameter is equal to 2 times the change in the radius, which is exactly what I thought, because the diameter is twice the radius. So the change in the diameter is 2 times that value, which is, of course, -1 over 20 pi. And that would be centimeters per minute. A little tricky, but not too bad. Okay, let's look at the next one. Okay, so I'm going to draw a diagram because diagrams are very helpful. And I've read the problem ones. Okay, so two cars start moving from the same point. One travels, so they leave from here. One travels south at 60 miles per hour. So I'm going to label this as dx dt is 60. And I wrote that as a rate because it said 60 miles per hour, kind of a hint. And the other one travels west, so it's going this way at 25 miles per hour. I'm going to call that one y. So the change in y is 25 miles per hour. And I want to know at what rate is the distance between the two cars increasing 2 hours later. So now this gives me some important information, because if my car is traveling for 2 hours at 60 miles an hour, I know that this length, I'm calling it x, must be 120. Because 60 times 2 for 2 hours would be 120. And at the same time, I know that this length, where it was traveling 25 miles an hour, must be 50, and I'm calling it y, because 25 times 2 is 50. And then once I know both of those, I must know this, because of course I made a right triangle, one south and one west, and so this is nothing more than a Pythagorean triple. So my hypotenuse, I can call it c if I want, is 130. Okay, so now if I'm trying to figure out the rate that the distance between them is changing, I'm looking for this rate right here. So I want to find dc dt. And of course the one formula that I have that I can use on my right triangles, and we talked about this in class today, is this formula. And if I want to involve rates, I'll have to do some deriving. And we derived this in class today. So I'm powering down each variable and then taking the derivative of the variable. And then hopefully I have all the stuff I need to plug in. So I've labeled them x and y. You could have called them a and b. As a matter of fact, we could call this x squared plus y squared equals c squared. And then these are all x's and these are all y's, if that makes it easier for you. Otherwise, this changing around of variables can be a bit confusing sometimes, and I don't want you to be confused, so you can just fix them. So I've got 2 times x, but x was 120, and then dx dt was 60, and then fill the rest in because I'm going to run out of tape here. So hopefully your equation looks like that, and then I'm going to do the math magic on it. So I multiplied everything on the left, divided by the 260, and a final answer, 65 miles per hour.